Okay, so we're going to draw two of the medians of a triangle. This subdivides the interior of the triangle into four pieces, three triangles, right? Three triangles and a quadrilateral. Show that two of the three small triangles have equal area and that the area of the third is equal to that of the quadrilateral. So basically, our goal is to show that this area here, A3, is equal to A2, and A1, this area here, is equal to this area here, A4. Okay, so let's go ahead and start the proof. So the first thing I'm going to do is I'm going to draw the height of the triangles respectively. So I'm looking at triangle ABX, and I'm going to draw a height where BX is my base. So I'm going to call that H1. And then I'm going to draw here a height here, okay, a height here for triangle ABY. Because basically my strategy is if I can show that ABX, the area of triangle ABX, is equal to the area of triangle ABY, then I know that A3 is equal to A2 because A1 is shared among them, right? And we'll call this height 2. Okay, so looking at this picture, I know the area of triangle, so ABX, is equal to 1/2. So for ABX, I established the height was H1. So for that height, my base is BX, and my height is going to be H1. And then for the area of triangle ABY, right? So ABY, I know that that is equal to 1/2. So the base I established for ABY is AY, right? That's the base of the triangle. So it's going to be AY times height 2. Okay, so now the next trick to do this sort of problem is we're going to look at the area of triangle ABC from the perspective of the height being H1 and the area of triangle ABC from the perspective of the height being H2. Okay, so we know that the area of triangle ABC is equal to 1/2. So if we're looking at H1, then the base is going to be BC times the height, right, which is H1. And we also know that the area of triangle ABC, right, so ABC, is also equal to, let's see, so if we do it from the perspective of H2, that means our base is going to be AC, so it's going to be 1/2 AC times height 2, right? So that's just looking at the area of the triangle from two different perspectives. So this tells us, so of course this tells us that 1/2 BC times H1 is equal to 1/2 AC times H2. Okay, so we know that BX, right? So basically we know that AX is the median, right? So that means X is the midpoint, meaning that BX is equal to XC. So instead of writing BC, I can write 1/2 times 2BX times H1 is equal to, and instead of writing AC, right, I can write 1/2 times 2 AY times height 2, right? Since I know that BY is the median of AC and AX is the median of BC, right? Since I know those two things, I can write this, which of course, this implies that BX H1 is equal to AY H2. Okay? So remember, I wanted to prove that area of triangle ABX is equal to the area of triangle ABY. And I'm really close. I have BX times H1 is equal to AY times H2. But in order to have the area of ABX equal to the area of ABY, I need to multiply both sides of this by 1/2, right? So this implies that 1/2 BX H1 is equal to 1/2 AY H2. And then, of course, this implies that the area of triangle ABX is equal to the area of triangle ABY. And then, of course, if I have ABX equal to ABY, that means A1 plus A3, A1 plus A3 is equal to A1 plus A2, right? And of course, if I subtract the area, if I subtract A1 from both of these sides, I get A3 is equal to A2. So I proved that these two triangles are in fact equal to each other, right? Now the last piece is to prove that A1 is equal to A4. So what I'm going to do is I'm going to look at triangle ABX and ACX. So I know the area of triangle ACX. So area of triangle ACX, right, is equal to 1/2. So ACX is 1/2 CX times height 1, right? The height 1 is still the same for ACX as it is for ABX, right? So ACX is going to be 1/2 CX times height 1, right? So now what we can do is we know this implies that the area of triangle ACX is equal to 1/2 CX times H1, but we know that CX is equal to BX because we know AX is a median, right? So I could just write is equal to 1/2 BX, right? 1/2 BX H1, which of course is equal to the area of triangle ABX, right? So ABX. So of course this implies that the area of triangle ACX is equal to the area of triangle ABX. And then this implies that A1 plus A3 is equal to A2 plus A4, right? So A1 plus A3 is equal to A2 plus A4. And earlier we proved that A3 is equal to A2, so I could just write this as A1 plus A2 is equal to A2 plus A4. And then subtracting A2 from both sides, I get A1 is equal to A4. So I proved that these two smaller triangles are equal to each other, and the area of these two small triangles are equal to each other, right? And the area of this triangle here, A1, is equal to the area of this quadrilateral here. And that is the proof.